Hey everyone. I'm back again with another tutorial showing another Blender trick that I came up with. This one is aimed at reducing noise in cycles in order to get faster renders, more consistent denoising results, uh, s- stuff like that. It's not a universal trick, I'd say, and you'll really have to mess around with some of the settings to get it to work with your scene well. But the general idea that I'm going to be showing here and most of the steps you can pretty much follow exactly to a T. I'll let you know what things you'll probably have to configure depending on your scene and like give tips on like, oh, if you're doing this kind of scene, then this is how you'll probably want to do this. Um, there's stuff that I'll explain when we get to it. So anyway, I have a scene here. Um, it's just a house interior scene. Uh, just so you could see this scene is from Blender Kit. Um, for those who don't know about Blender Kit, it's a plugin that you can use to access a huge library of assets for Blender, and you just click on a button to import them right then and there, right into your scene. Um, it's free, but most of the assets are only available under the paid subscription. Uh, this house model, particularly this house interior, is actually one of the free assets. So if you want to use this one, then you'll be able to find it on Blender Kit, and it's just called Model House by Jan Holinka. I hope I pronounced that correctly. And yeah, you could find out more information from it. Uh, I'll probably link it in the description, so that way if anyone wants to download it, they can get it right there. And also to give credit to the person who made it. But as you can see, I've turned off all of the lights inside of this house, and I am just lighting it using the outdoor HDRI lighting, which, if you've worked with interior scenes before in cycles, you'll know that that tends to create a lot of noise. See, this is a pretty noisy result here. Um, but the trick that I'm going to show you will reduce that noise by quite a bit, depending on your scene, of course. So let's get started. The the basic idea of this trick is that rather than calculating all of the light accurately, the way it would all the light bounces accurately, the way they would be just by default, we're actually going to fake some of the light bouncing so that so that the Blender doesn't have to do as much work in doing actual path tracing calculations to render our image. So the first thing we're going to want to do is we're going to want to add a second camera to our scene. Um, Once you have a camera in there, you'll want to clear its rotation, since by default, Blender will set your new camera's rotation to whatever the viewport rotation is. So now we have a new camera, and I'm just going to drag it into the scene here. And I'm going to lift it up a little bit, probably put it right about here. And what we want to do with this camera is we want to put it fairly close to the center point of our scene. You can see this is a whole house. This house has multiple rooms and stuff going on, but I'm only concerned about the kitchen. So I'm going to try to place this camera in the middle area of the kitchen. It's a little difficult because of how small this space is, but I would say that's pretty good. We don't want it to be close to any, like, one surface, so you try generally to keep it away from any one surface. Once we have our camera in, we'll rotate it by 90 degrees on the x-axis. So now we have another camera in our scene. We'll go to our scene tab here and switch to that camera. So now if I go into camera view, we're in this camera instead. And this just lets you, so you can keep your original camera here. If I switch into render view now, we can go into our camera settings, and we're going to want to switch this camera to be panoramic. And instead of fisheye, we're going to set it to equirectangular. So if you've ever rendered your own HDRIs, that's basically what we're doing here. But instead, we don't really need a whole lot of resolution, so I'm just going to set this to 128 by 128. You really don't need a lot of resolution, and if it's a lower resolution, then this HDRI will render pretty fast. Once we have that set up, we're just gonna hit render. I'm gonna switch over to my compositing tab since that's where the image is, and that should be reasonably quick. Like, this took 2 seconds for me because it is just a tiny image. And so we're gonna save that. Since this is an HDRI, I'm gonna save it as an OpenEXR. You can turn on compression and stuff, but for an image this small, you probably don't need it. But I'll do it anyway, just because. And I've already done this once, so I could show before and after images. But, yeah, I'll save this. And now we have our HDRI saved. Anyway, now that we have our HDRI, we're going to come back to our scene. And I'm just going to reset everything back to how it was before we rendered the HDRI. And, let's see. Switch back to our main camera again. And now here's how we actually implement that. So a little setting that you may not have noticed in Blender is under the Light Paths tab, there is this setting called Fast GI Approximation. And also, if you've ever had to render out an ambient occlusion pass and you wonder where the heck do I change the ambient occlusion distance, it's here. It's kind of annoying that it's not really. It used to be in the world tab, and then they moved it, and nobody knew where they moved it to, but this is where it's at now. But if you turn this setting on, you'll notice, oh, my scene looks like crap now. That's because at least here the ambient occlusion distance is way too high. It's set to 10. Depending on your scene, this is one of those things that you'll have to change depending on your scene. I find if you're just doing interiors like this, a setting between 1 and 3, maybe even 5 gets the job done, but I'm gonna stick to 3 because this shadows a lot of the areas that I want to be shaded, but still it doesn't overshadow it. Now if I switch back to combined view, you'll see, wow, that looks very bright because my skybox here is very bright. And so the solution to this is that we want to use that HDRI that we just rendered as the light source. Because what this option does is basically whenever a ray trace calculation is done, whenever it sends out a ray from the camera and it hits something and bounces off, rather than actually bouncing around and trying to calculate the light, it's just saying, oh, how dark is this spot on the ambient occlusion pass? And it's like, and then bouncing off and grabbing the world, the skybox, and using the ambient occlusion as a darkener, essentially. So it's not actually calculating real bounce lighting, it's just hitting the object, bouncing off, and then going straight to the world and ignoring everything else. Which is fast, but not accurate. And we want to introduce at least some fake accuracy to this. So, yeah, if you notice that a few graphical glitches up top here, I don't know, it's an OBS thing. I can't seem to fix it. I'm wondering if maybe it's just a Blender thing, but I've tried fixing it and I can't seem to get it fixed. So, anyway, we're gonna want to go into the world node settings of our scene. I switch back into render. You can see this is where our HDRI is. It's very bright because this is an interior scene. We're gonna duplicate our background, or rather, we're gonna duplicate our HDRI and our background. And for this one, we are going to go and select our environment map that we rendered before. So now if we set that as our skybox, let's see, it's way too bright. We want to set it to 1. The lighting is a lot darker than it's supposed to be, but we're going to fix that. One problem is that you'll notice that it's rotated the wrong way. So I'm using Node Wrangler, and I just hit Control T to assign a mapping node and texture coordinates to this, but to set those up, you just go input, texture coordinate, and then vector mapping. We're just going to rotate this by negative 90 degrees, and that should be actually lining up with our scene. So now, I'm going to go into our fake GI settings again, or fast GI settings again, and depending on your scene, you'll increase the viewport bounces, or both the viewport and render bounces here, to get more accurate lighting. There is one more thing we got to do before we mess with that, and that is we want to make sure, because we don't want our room here to show up outside the window. So we're going to take a mix shader here. We're going to bring this down to the bottom notch. Bring this one to the top notch. So we have our actual skybox, and then we have our fake one. And now we're going to use a light path node, and we're going to use isDiffuseRay as our factor. So what this does is this just makes it so that this fake skybox that we made, this HDRI that we made, only shows up in diffuse rays. So whenever a light hits whenever the path tracer hits a object that has a diffuse shader, or has a higher roughness in principled shader, it'll use that instead, while anything glossy or transparent or translucent or uh emissive, whatever, when a ray hits that surface and bounces off, it just treats it it just goes to this one instead. It goes to our skybox instead, which is what we want, because we don't want our fake uh our little environment map here. We don't want that to show up in reflections or anything. We only want it to contribute to diffuse rays, since those are the only ones that contribute to global illumination for the most part. I'm going to turn denoising on, and as you can see, if I turn the fast GI on and off, it doesn't look all that accurate. Depending on your scene, it may look more or less accurate. And this is one of those things where you're just going to have to fiddle with it. And like I was saying before, you'll have to adjust the number of real bounces. So what this does is basically, this changes the number of times that a ray will bounce around the scene before just giving up and saying, okay, I'm just gonna check what the I'm just gonna check what the world shader has going on, and not worry about bouncing anymore. So the higher you have that value, the closer it's going to look to your actual scene. Depending on your scene, you may be able to get away with just one bounce. Usually not, especially if you have characters that have subsurface scattering and stuff like that. Probably not going to look very good. But 2 bounces is usually enough. For scenes like this, I would say it's not quite enough. And I would go up to 3. If I turn this on and off, you'll notice the result is not all that different, visually speaking, than, say, with only 2 bounces. You can notice a definite difference there. And what I'm going to do is, I already have some rendered versions to show you. Because at this point, you would just configure these settings when you figured out what settings work for you. Make sure you also set the render bounces to that, so that they both match. Otherwise, it's only going to affect the viewport and not the render. But anyway, I'm going to bring up some before and after comparisons. So this is before we applied global illumination, and this render took 31 seconds. So, and here is the after with 3 bounces rather than but yeah, that's 3 bounces. So before and after with 3 real bounces. And here it is with 2 bounces. We have the before with real global illumination, and after with the fake global illumination with 2 bounces. The differences are very subtle most of the time. As you can see, with just 2 bounces in a scene like this, it makes a pretty dramatic difference. I would say the 2 bounces is still okay. It's not perfect. Especially, you'll notice things like the faucet over here don't look right in comparison. And then with 3 bounces, the difference is much more subtle. But the major advantage that you get here is that time save, and with the time save is pretty decent especially if you're doing animation. I mean, the difference between these two renders is very small. But you do save an additional 5 seconds of render time, which, if you're doing an animation, that adds up pretty quickly. And if you're doing only 2 bounces, um, I would not stick to one. I would always go with at least 2. But if you're doing 2 bounces, you've saved 10 seconds, which is quite significant for animation. But yeah, this part will pretty much be up to you to dial in the settings for your scene. For most outdoor scenes, you can probably get away with 2 bounces just fine, but I would say for an indoor scene like this, definitely go up to 3 and never do 1. Like, you can try 1, but 90% of the time it's going to look terrible. So I would do at least 2. And I would say 2, even 2 looks pretty good. Um, and if I turn it on and off, the difference is subtle, but it's not. It'll all come down to what you think is a good enough compromise for your animation. And if you're trying to do something that's perfectly photorealistic, again, I'm a person who does more stylized stuff. So getting perfectly accurate lighting isn't really important to me. What's important to me is making lighting that looks good, not real. Um, so for me, this might be good enough for me, but for you that might not be good enough. And but like the differences with higher bounces get very subtle, and especially with outdoor scenes, I would say, um, you can get away with a lot less real bounces because you're usually dealing with the natural lighting of the scene. Um, but yeah, that's the trick I wanted to show everyone today, and hopefully hopefully you find it useful. Uh, it does take a bit to set up, of course, but if you're rendering an animation, the extra 10 minutes, 20 minutes or so it takes to set this up is going to matter much more in the long run because it's going to save you like hours of rendering time. If you're rendering like uh, a 10-hour, if an animation is going to take you 10 hours to render, um you probably save like an hour, maybe half an hour on your render times, and maybe even more than that. And that really adds up, and it's I'd say it's worth the setup, depending on how long your scene takes to render and how long your animation is. Yeah. Hopefully that was useful for y'all. I'll see you later.